Welcome to your first lesson in topic 5. This topic is all about soil systems and society. Soil systems are really important to human populations because obviously it's where we get a significant amount of our food. So how soil systems work and the treatment of soil systems is a big topic in this course. In this introduction to soil systems, we're going to be looking a little bit at what defines a soil system and what it contains, and how we can talk about the characteristics of different kinds of soil. So let's get started. The first thing we need to do is define soil. So soil on its own is a complex and dynamic ecosystem. It is a system where there are inputs and storages and outputs. And since it's dynamic, materials are constantly moving between the inputs, the storages, and the outputs. So let's take a look at what some of those are. The storages in a soil system are organic matter, minerals and nutrients, air, and water. The inputs are obviously organic matter through things like leaf litter and decomposing organic matter like dying animals, leaf and animal. Precipitation is what brings water into a soil profile. And then you also have minerals brought in to a soil profile from bedrock below that is being weathered up into the soil. The outputs from a soil profile are uptake of nutrients by plants, and this is the beginning of any food chain, is when plants can take nutrients like nitrogen up into their body structures and use them to provide nutrition to other organisms. And soil minerals are washed away or blown away through the process of erosion. So that's sort of the basics on how soil acts as a system. Let's look a little bit now at the different layers of a soil profile. So when you look at any soil profile, there are what we call soil horizons present. The soil behaves in a different way based on how deep in the earth it is. And the depth of these different horizon layers can vary based on the kinds of mineral particles that are present, but these different sections of soil are always present. So at the top you have organic matter that is either growing in the soil or being decomposed into the soil. The next layer down is called the surface. This is where some root systems start to be present. There's a lot of air in this layer to allow for particles to move up and down. The next is the subsoil layer, and this is a really important part of soil because if you look here, it's where a lot of plant roots end. So it's significant to have a lot of nutrients in this subsoil layer so that plants can grow strong and healthy. The next layer is the substratum, and this houses bedrock material that's being weathered into the soil profile. Things obviously have the ability to move up and down through this soil profile, and we call that process translocation, the movement of any material up or down through a soil profile. We say that salinization is occurring when things are moving up, and generally the condition that needs to be met for that to happen is evaporation. It needs to be greater than precipitation because particles move with the water molecules through the soil. So as water moves up, if evaporation is greater than precipitation, it brings different mineral salts and other matter with it. And they usually form sort of like a crusty layer up at the very top of the soil that looks like salt, and that's why it's easy to remember this is called salinization. Generally, high levels of salinization are not great for soil because then the stuff that lives here has a hard time breaking into the rest of this healthy soil down here. Leaching is what we call it when things move the other direction. And just like salinization, too much leaching is not great for soil because it washes away all of the minerals and nutrients. So if its precipitation is much greater than evaporation, water is going to be constantly flowing down through the soil and dragging with it all of the minerals and nutrients that these plants need to survive. The kinds of mineral particles that you have present in your soil contribute significantly to how translocation occurs. So let's take a minute to talk about some of the different mineral particles that are present in soil. There are three sort of classes of particles: clay, silt, and sand, and that's in order from smallest to biggest. Clay soils tend to not have very good drainage because the particles are so small. And sand soils tend to have too good of drainage because the particles are so big, there's a lot of air between them. So when we create soil systems to grow food in, we generally try to create soil that is a mix of these particles. And ecologists have created this soil system triangle that you can use to tell how much of different kinds of particles are in a given kind of soil. And sometimes on your IB exams, you are expected to be able to read these profiles. So let's take a minute to review how you do that. If we wanted to know the concentration of each kind of mineral in this silty loam soil here, we would do three things. I like to start on the silt side and think of it as drawing an arrow down from the silt side to where my soil is present. So here we're at about 55% silty soil because we're between the 50 and the 65. Then I keep going around to the sand and I draw an arrow to the left of where the sand line is. So here we're at 35 because we're between the 30 and the 40. I'm just going to draw these in so we don't forget them. Then it gets a little bit simpler. For the clay, I just go straight across and I end up with 10% clay. So for a silty, loamy kind of soil, one possible percentage concentration of each mineral is 55% silt, 35% sand, and 10% clay. And we'll talk about why that mix of different minerals is important in the next slide. So let's go ahead to that. When you talk about soil characteristics, there are four basic things that you can talk about. Porosity, which is the space between particles. Permeability, which is the ease with which gases and liquids flow through soil. pH, which is the acidity or the concentration of hydrogen ions in the minerals in the soil, and the nutrients that are present. The most important nutrients are nitrates, phosphates, and potassium. So sometimes we abbreviate soil nutrients with NPK. This is the easiest one to manipulate. We can change the nutrients that are present in soil pretty quickly by adding a fertilizer. pH is relatively easy to manipulate because we can add acidifying agents or agents to make a soil more basic, like lime. And porosity and permeability we're kind of stuck with. So these two characteristics, we like to have sort of an intermediate amount of space between the particles, of space between the particles, and also of ease with which materials flow through soil, because we want things to be able to move through the soil profile but not too quickly, so that the nutrients that plants need have time to be absorbed by the organic matter in the soil. So when we look at healthy soil, the soil that gives us the healthiest balance between all of these things, I'm going to go back just for a second, is usually some kind of a loam-based soil. And it's true that different kinds of plants grow in different kinds of soils. But overall, when we look at food production, we say that loam is the best soil in terms of all these characteristics. So loam is best. And this will be significant in your homework questions. So keep that in mind. If you want to watch a film about the importance of soil, this Dirt the Movie is a great film. If this link doesn't work for you, you can search this up on YouTube, Dirt the Movie. The version that I'm always able to find has like subtitles in a funny language, but it's in English, and it gives you just a good idea of how important soil really is, because I think it's not something that people think about a lot. So let's move on for now to your homework assignment. If you are reading along in the textbook, you should be looking at pages 236 to 244. And you are going to try to complete the following comprehension questions. First is sketch a model that outlines inputs, storages, and outputs in a soil system. And the second is state the best type of soil for growing crops and explain, so give reasons for its characteristics. Make an attempt at those, and when you are ready, check your answers in the review video, and I will see you there.